Hello students, you are most welcome with Dr. Virpal Singh with new topic, that is new engineering material CNTs. Okay, now come on, that several point of this topic which are very important to be discussed today. Point to be discussed: definition of carbon nanotubes, preparation of carbon nanotube, classification of carbon nanotube, properties of carbon nanotube, and the application of carbon nanotube. As you know, this is new topic, and because of this new topic and its several very important properties of this topic or CNTs, it has reserved its application and its utility in the today life. Now we discuss about this topic in detail. Carbon nanotubes. Carbon nanotubes are the allotropes of carbon. As we have earlier discussed in previous lectures about the carbon has the important property, that is allotropism, and this CNT is also the one of its property, that is allotropic form of carbon. So these cylindrical carbon molecules have interesting property that make the potentially useful in many applications in nanotechnology, electronics, optics, and other field of materials science, as well as potential use in architectural field. They exhibit extraordinary strength and unique electrical properties and are efficient conductor of heat. Their final usage, however, may be limited by their potential toxicity. So this is the example which indicating the structure of the carbon nanotubes CNTs. This is again the example which explaining the cylindrical structure of carbon nanotubes. This is the again multi-concentric structure of cylindrical carbon nanotubes. So with this explanation of the structure of CNTs, now we just come on CNTs preparation method or technique through which we prepare the CNTs. Arc discharge, that's very important method of preparation of CNTs. CNTs can be found in the carbon shoot of graphite electrode during an arc discharge involving high current. This process yields CNTs with length up to 50 microns. The second method of preparation of CNTs is laser ablation. In this method, in the laser ablation process, a pulse laser vaporizes a graphite target in high temperature reactor while an inert gas is inserted into the reactor. Nanotube develop on the cooler surface of the reactor as the vaporized carbon condenses. The other important method of preparation of CNTs are chemical vapor decomposition, natural, incidental, and control flame environments. So these are the method through which we can prepare the CNTs. So these are the example of CNTs which indicating is its strengthful structure and cylindrical structure of CNTs. Now come on the important topic of CNTs, that is its properties through which it preserves its place of important application in our life. That is strength, electrical property, thermal property, and with these advanced properties it also has some demerits, and one-dimensional transport property and its toxicity. Strength properties, this is very important and very useful or merits of this CNTs, that is carbon nanotube have the strongest tensile strength of any material known. So this is the best and important property of CNTs. This second point is it is also has the highest modulus of elasticity. So the highest elasticity and strongest tensile strength make its application, make its extensive application. Second property, that is electrical property. If the nanotube structure is armature, then the electrical property are metallic. If the nanotube structure is chiral, then the electrical property can be either semiconducting with a very small band gap. Otherwise, the nanotube is a moderate semiconductor. In theory, metallic nanotubes can carry an electrical current density of 4 into 10 to the power 9 ampere per centimeter square, which is more than 1000 times greater than the metal such as copper. So this is the cylindrical structure, which is make it more important and indicating its electrical properties. Thermal properties. All nanotubes are expected to be very good thermal conductor along the tube, but good insulator literally to the tube axis. It is predicted that carbon nanotubes will be able to transmit up to the 6000 watts per meter per Kelvin at room temperature. Compare this to copper, a metal well known for its good thermal conductivity, which transmit only 385 watts per meter per Kelvin. So what a important property of thermal conductivity. The temperature stability of carbon nanotube is estimated to be up to 2800 degrees centimeter in vacuum and about 750 degrees centimeter in air. Defect. With these property which is discussed earlier, it makes its application, but this application is confined because of its demerit, that is defect. Defect can occur in form of atomic vacancies. High level of such defect can hover the tensile strength by up to 85%. Because of very small structure of CNTs, the tensile strength of the tube is dependent on its weakest segment in a similar manner to a chain, where the strength of the weakest link becomes the maximum strength of chain. One-dimensional transport. Due to their nanoscale dimensions, electron transport in carbon nanotubes will take place through quantum effect and will only propagate along the axis of tube. Because of this special transport property, carbon nanotubes are frequently referred to as one-dimensional. As we have discussed earlier in this chapter about the merit and demerit, finally decide their application, that is we are going to discuss. Application 1. Nanotube hold the promises of creating novel devices such as carbon-based single electron transistors that significantly smaller than the conventional transistors. Nanotube excellent strength to weight ratio create the potential to build an elevator to space. Third one, quantum computing. Nanotubes and other fullerenes can be filled with molecules that have either an electronic or structural property which can be used to represent the quantum bits qubit of information and which can be associated with other adjacent qubits. Health hazards. It is an important aspect of life. So we just see the use of the CNTs in health fields. According to the scientists, a National Institute of Standards and Technology, carbon nanotubes shorter than about 200 nanometers readily enter into human lung cells, similar to a way asbestos does, and may poses an increased risk to health. Carbon nanotubes, along with the majority of nanotechnology, are an unexplored matter, and may of the possible health hazard are still unknown. Revision point. Whatever the point we have discussed in this lecture, now we come just on the revision of these points. Just we have studied in this chapter about the carbon nanotube, its definition, its preparation methods, how many methods we have prepared the CNTs, we have discussed in the chapter, and the classification type of the nanotubes have been discussed. Properties of carbon nanotubes have explained in details, which make it the extensive use or application of carbon nanotubes. So these are the points which have discussed in this in our today classroom. Now before to say thank you to all of you, I like to say please like and subscribe YouTube channel of Dr. Veerpal Singh. That's name is Dr. Veerpal Singh. Thank you very much.